Hello, this is FRQ 2006 number 3, and it is given dx over dt and dy over dt. And basically this is x prime and this is y prime. Letter A asks for the acceleration vector and the speed of the object at time t equals 2. So for letter A, we're going to find x double prime and y double prime. In order to find these, we're going to have to find derivative of x prime and y prime. And how we're going to do this is we're going to plug it into the calculator and we're going to press F3 and go to 1, differentiate, and in the parentheses we're going to type in dx over dt and dy over dt. And I just put t as x because it's easier to enter in, but it really doesn't matter if you put t or x. So after you plug these in, I just did in terms of x, so I put comma x for both of these. And after you press enter, you're going to get the equation, which is the derivative of x prime, which is x double prime. And in that x double prime, we're going to just plug in t equals 2, because the question asks for at time equals 2. And after you plug in time equals 2, you're going to get the answer 0.395 and negative 0.741, which is the answer. So we're just going to write the answer 0.395 and negative 0.741. For the second part of letter A, you're going to find the speed of the object, which is root of x prime squared plus y prime squared. And how you're going to solve this is you're just going to square both of them and plug in t equals 2. And that's how you get the answer for the speed. And for the speed of the object, you're just going to use this equation to find the speed. For part B, it says the curve has a vertical tangent line at one point. At what time t is the object at this point? So we're going to find the slope first, because that's how we find where the vertical tangent line is. So the slope is basically dy over dx. So dy over dx equals dy over dt over dx over dt, whereas this equals dy over dt times dt over dx. And these two cancel out, so therefore it's going to be dy over dx. And for the slope, we're just going to plug in these two equations inside here, which is going to be 4t y plus t cubed times 1 over arc sine of 1 minus 2e negative t. And after you find this, you would realize that when dx equals 0, it's going to be vertical asymptote. And in order for this to have the vertical tangent line, dy cannot equal 0, or else it's going to be 0 over 0, which is undefined. So to find where dx equals 0, you're going to plug it into the calculator like this, F2, and then press 1, which is solve, and then you plug in dx over dt over here and set it equal to 0. And then you're trying to find t, so you're going to put comma t. And after you plug this in, it's going to give you the answer t equals ln 2, which is 0.693. So at this point, we have to see if dy does not equal 0. So we're going to plug in 0.693 into this equation, and it does not equal 0. So therefore, at t equals ln 2, it's going to have the vertical tangent line. And for part B, for letter B, we don't have to do all of these, but as just to prove that it has a vertical tangent line when dx equals 0. I just wrote this just in case. But we can see that in always the slope, if the denominator is 0, it's going to have a vertical asymptote. And just remember that the top cannot equal 0. And also, when you're plugging all of these into the calculator, it should be in the radian mode, not degrees. For part C, it says let m of t denote the slope of the line tangent to the curve at the point x of t, comma, and y of t. Write an expression for m of t in terms of t and use it to evaluate limit as t goes to infinity of m of t. So write an expression and evaluate. So the expression of m of t is basically what I wrote right here, because this is the slope, which is going to be exactly the same as I wrote before, times 1 over dx over dt, which is arc sine of 1 minus 2 e to negative t. And that's m of t, and we just wrote an expression for it. And now we're going to evaluate limit of m of t as t approaches infinity. So how we're going to do that is through calculator again. So in the calculator, we're going to type in define in order to define m of t as the slope, like I wrote here, just to make it easier to find the limit, because we don't have to just plug in the whole equation right here, but we can just put m of t since it's already defined right here. And f of 3, and then press 3, which is limit, and then write m of t, which is the function, and t, comma, infinity, which means t approaches infinity. And after you type that in and press enter, it's going to give you 0. And therefore, limit of m of t as t approaches infinity is 0. And now we're going to move on to letter D. It says the graph of curve has a horizontal asymptote y equals c. Write, but do not evaluate, an expression involving an improper integral that represents this value c. So we can first start with saying that limit of x of t as t approaches infinity, which is 6 plus integral of dx over dt in terms of x from 2 to 8, which is infinity. And now we can see that it has horizontal asymptote y equals c. Since dx approaches infinity, anything on top, basically it's going to equal to 0. Since small number over big number, such as infinity, would equal 0. And now we have to find what y of t is when limit goes from t, limit is t approaches infinity. So basically we're going to find limit t approaches infinity of y of t, which is going to be negative 3, because at t equals 2, the point is 6, comma, negative 3. So this is the y value. Plus, since t equals 2, it's going to be 2 to infinity of dy over dt in terms of t. And that's the expression involving an improper integral that represents this value c.